Hi, this is a video on projectile motion for a vertical launch. There are different kinds of projectile motion. The vertical launch is in many respects almost identical to free fall. The difference is if you're dealing with free fall, almost all of your horizontal motion is going to be zero. So your x position is going to be zero, your acceleration, all these would be zero for a vertical launch. It's only the for a free fall. For free fall, which is just falling straight up and down, these would all be zero. These wouldn't be, but these would. For a projectile launch like this, no longer are you not moving in the x direction. In fact, let's take this example here. A car is about to drive off a cliff. That cliff is 50 meters high, and that car is moving at 10 meters per second. You might ask, how far is it going to go when it crashes, or how far has it gone when it crashes? And if you want to figure out that distance, for example, or other things, say that's the distance, d, you're going to have x motion and y motion. So for a problem like this, since it's not free fall, you have x and y motion. Keep in mind a few important things. Gravity. Gravity always points down towards the center of the Earth. It pulls on us towards the center of the Earth. This means gravity is only pulling in that vertical direction, in that y direction. So if we say that up is positive and right is positive, gravity is pulling in the negative direction. So we're going to say that the acceleration in the y direction is negative 9.8 meters per second squared. It is not accelerating the car at all in the vertical direction. So the car starts at 10 meters per second in the vertical direction because it's driving straight to the right when it launches off the cliff, and it stays at that same speed forever and ever. So if there was no bottom to the cliff, it would still be moving at 5 meters per second in that vertical direction, or that horizontal direction forever and ever and ever. So V and V naught are both 10 meters per second square, 10 meters per second, and the acceleration is 0, meaning that this never changes. So let's look at what happens to the car realistically. Realistically, it goes off the cliff, does a nice kind of trajectory like that. You can see it's a curved trajectory, sort of like a distance time graph would be curved, and it hits at this point. The question is, where is this point? How far did it go? I put the distance d there. If you want, you could just put a distance x, because now we recognize this is a projectile motion problem. This is just a distance in the x direction, so that's what we're looking for. X right there. Despite the fact we have 3 variables here, we cannot solve for x. This is one of those rare occasions where you need more than 3. We need to find the time. In order to find the time, we need to solve this side right here. So let's figure out what we know. Initially, might be moving at 10 meters per second, but that motion is all completely horizontally. None of it is in the y direction, so the initial speed in the y direction is 0 meters per second. So we've got 2 variables now. There's just 1/3 variable that we need. That's going to be the y distance, right? In this case, it's moving 50 meters, but that's in the negative direction. So the total distance traveled is negative 50 meters. Let's get our signs correct. It'll work out pretty much if, well, sometimes it'll work out if you don't get your signs correct, but let's make sure we get them correct, just to make things easier. So again, we don't know the final y, but we don't need to. We'll just use this one. Y equals V naught t plus 1/2 at squared. And we know y is negative 50 meters equals 0, because that velocity is 0, plus 1/2 acceleration is negative 9.8 t squared. So t ends up equaling 2 times negative 50 divided by negative 9.8 meters per second squared. You can put that into your calculator. It should be around 10, right? It's about 100 divided by 10. 10.2. And you notice that not only do the units work out, sorry, that should be t squared. So t is the square root of 10.2. Not only do the units work out, so this is why we look at units, because I realized that there was a square in there. The signs work out too, those two signs cancel each other out. So you get the square root of 10 seconds squared. So the time is equal to 3.2 seconds. Good deal. So we know it takes 3.2 seconds to hit. .2 seconds later it hits. Now we have enough information to figure out where. So we can say x equals, what's a good one? Let's see what we got here. We got 4 variables. We can use lots of different solutions. I'm going to make this a little simpler, because I could have used this, or this equation. Any of those would work. But I'm just going to pick the one that's this one over here. 1/2 times initial velocity. Oh, never mind. Let's try it and see what happens. You'll notice it doesn't work. 1/2. Oh no, never mind. What am I saying? It doesn't work. Of 10 meters per second is initial velocity. Plus, the final velocity is also 10 meters per second times the time of 3.2 seconds. So you end up getting 10 plus 10 is 20, but 1/2 of that is 10. So 10 meters per second times 3.2 seconds. This is in essence just the average velocity times the time. Because you can say distance is average velocity times time. So you end up getting 32 meters. That's where it strikes. 32 meters. I didn't solve for the velocity in the y direction, but you have the tools to do that at this point. So I encourage you to do that on your own right now. And this is the end of the projectile motion vertical launch. Although I would encourage you to keep in mind that there are all sorts of variations on this that you can have with different variables that you know. So maybe you don't know this distance, but you're trying to figure out, like, you know x, but you don't know the height. So you might actually start with the x direction, then work to the y direction. So how you solve this depends on what you're given. Thank you.